We're going to do extra example 1 from the textbook. We're going to solve the system by elimination, and the system is 8x minus 6y plus 2z equals negative 20. Negative 3x plus 6y minus 15z equals 51. And 2x plus y plus 3z equals 0. I'm going to call this one equation 1, this one equation 2, and this one equation 3. So the whole point of the elimination method is to eliminate a variable, and we're going to do that using the addition property of equality. So we're going to add 2 of the equations together in order to cancel a variable. So I said that you are going to eliminate the variable of your choice because it doesn't particularly matter which variable you eliminate. However, sometimes it's already set up to eliminate one and we'll have an obvious choice. In this one, I believe we have an obvious choice right here because we have opposite coefficients. So when we add equation 1 and equation 2 together, we're going to eliminate that y. So when we have 8x minus 6y plus 2z equals negative 20, and negative 3x plus 6y minus 15z equals 51, we're going to add those 2 equations together. So that we cancel out the y. So 8x minus 3x, or 8x plus negative 3x is 5x. The y's cancel out. And 2z minus 15z, negative 13z equals 31. So the next thing that we're going to do is choose 2 different equations to eliminate the same variable from. So since we eliminated y the first time, we're going to eliminate y the second time. So I'm going to use equation 1 and equation 3. So 8x minus 6y plus 2z equals negative 20. And if I just write equation 3 as it is, will I have y cancel out? No. So I need to algebraically manipulate it to make that happen. All right. So what do I need to multiply equation 3 by? 6. When I do that, what do I get? What? 12x plus 6y plus 18z equals 0. And we're going to add those together so that we eliminate the y. So 8x plus 12x plus equals negative 20. And now we have a subsystem that we can solve. And why don't we solve it by elimination? So here's one of my equations for the subsystem. Here's the other one. So we're going to have 5x. Oh, will we be able to add them together straight away? No. So what should I do to the first one? Multiply it by 4? Negative 4. Why does it need to be negative? So it cancels out. So we're going to have negative 20x plus, what's 13 times 4? 52 equals what's 31 times 4 or negative 4? Negative 124. And so now we can solve this subsystem we can stick with our elimination method by adding these two together now. And what happens to the x's? They cancel out. They get eliminated. And what is left? And then we are going to divide by 72. And what is negative 144 divided by 72? Negative 2. So we have our value of z. What do we do with it? Plug it into one of these two equations. Does it matter which one? No, doesn't matter. So which one would you prefer? Could we also maybe plug it back into the original one that we got up here before we manipulated it? Sure. It's got smaller coefficients, so why not? So we have 5x minus 13z equals 31. Did I transcribe everything correctly? Yes. Okay. It's very important to check that, because it's a real disappointment when that's the error you made, is you copied something down wrong. So we're going to have 5x. What's negative 13 times negative 2? Positive 26. And what do I do next? Leaving me with 5x equals what? And divide by 5. What is the value of x? 1. Now what do I do with x and z? I'm going to substitute those back into one of the original equations. and solve for that same variable that we eliminated the first time. Does it matter which one? No? So which one should we choose?
Equation 3.
Why equation 3?
Because it has
Because y is by itself. What's the coefficient of y? 1. So we won't have to divide by anything at the end. So we have 2x plus y plus 3z equals 0. And x was 1, z was negative 2. Now we can solve for y. 2 plus y minus 6 equals 0. Combine like terms, y minus 4 equals 0. Then what do I do to solve for y? Add 4. So y equals 4. So we have our solution. What is our solution as an ordered triple?
1, 4, negative 2.
1, 4, negative 2 is our solution.